I'm actually doing work for once. I'm here to do an EICR. Now, the homeowner's just bought this place. Looks in reasonable nick, but no paperwork. So I'm here to do a full 100% test. Normally, if you have a certificate, you could just, confirm the results. But in this occasion, they actually want to know everything that's wrong so they can get it fixed and enjoy their home. So, what do we do first? Well, first you've got to get permission for pretty much everything. That you're going to be turning power off, that you need access everywhere. You might want to give them a heads up if there's anything they don't want me to see, hide it away. I've done all that, gave them plenty of warning. But if you were in an office block, sometimes getting access to different cupboards and things like that takes time, so you need to give them forewarning. Anyway, this is a simple one-bed flat in a basement in the middle of Brighton. It's it's a lovely little flat actually. I really like it, but we need to make sure it's safe. Looks are very deceiving. Just because it looks nice doesn't always mean it's safe. So first step for me is to just map out what we got. Now, I've already started that. I'll show you that in a sec. And essentially what it is, just a bit of paper, rough top view of the entire flat, room by room, and then I'll just mark where the switches are, the lights are, the sockets are, any spares, cooker isolators, all those kind of things. And that's going to help me later produce a report. I like to do a detailed report really, rather than just the standard forms from the IET or maybe even NAPIT desktop, NIC software, those kind of things. I like to just make it a little bit more easy for the homeowner to understand. There's not really much point spouting reg numbers at them. They're not going to understand that. So it needs to be in a language that they get, and they can understand how dangerous or how, if it's just an inconvenient problem, those kind of things need to be explained. So mapped it all out. I'll get that. And this is what I'm talking about. Just, scribble it down, just the locations. And then what I can do in a minute, I'm going to work out what circuit each point is on and just write that next to each symbol. Also, as I do the testing, I can write down my R1, R2s at each point, and later that will help me interpret whether anything's abnormal or if everything looks okay. So, we've done that. Next thing to do is go through the schedule of inspections. You're going to have a good look around and just note down anything out of the ordinary, anything that doesn't quite look right. In this one, Pelmet lights underneath, the clips are giving way, so the cable's starting to sag down. But I'll show you the things that I found. We already know that there's a fault on the boiler circuit. MCB won't hold in at all, so that's probably a screw gone through it during some kind of refurb recently. Kind of draws up questions about how they got a gas safety certificate. How did they power it up? That's the question. They could have done what the homeowners had to do and just put it on a plug top for now, but yeah, interesting one. So hopefully I can find that fault and solve it for them. Otherwise it might be a rewired circuit, but I'm trying to avoid that. So schedule of inspections next. And there's a big long list of all the things you need to inspect on the model form from the IET, or if you're using like a certification software, they've got all of them there. And you just go through and answer questions really. If there's anything on that list you don't understand, then you probably shouldn't be doing these EICRs. You can look them up. There's normally a reg number next to it, next to the statement, so you can get an idea of what it's about. But this is a job for people who are knowledgeable, not blowing my own trumpet. I've just done it a lot. But yeah, you need to understand what you're looking for. If you please don't do it, because you might miss something really dangerous. So go through them schedule inspections, and I'll edit that in later. I haven't got my computer with me. I'm going to write all my notes and write it all up later. I just prefer to do that. And I'll edit that in. Next thing is continuity of bonding conductors, because you know, that's your kind of main method of protection really against shock during a fall. So it's normally the first thing we start with, continuity of all conductors in a general term, but I'm going to start with the bonding conductors, the gas, the water, and then I'm going to go on to my R1, R2s, and then I'm going to do some insulation resistance for all the circuits, and then I'll do my ZE, and then I'll check any RCDs, prospective fault currents, etc. So, see you in a sec.
Okay, so schedule of inspections. This is actually the end of the report, so it's a bit like a Tarantino movie, this. You've gone forward in time and then you're going to go back to the report in a minute. Cool. But these are the observations that I've been coming up with, and most of it's come from the inspection of schedules, which are come a little bit later. But obviously the boiler circuit got a C2, and there's a bit of a strange thing. They've got two gas bonds. So I need to do some more investigation, because it looks like they've put another one thinking that the other one had failed, but I actually got a good reading on the original one, so it needs a little bit more thinking about that. But here are the questions that you get offered, and we're just going to go through, and we've got the outcomes at the top here. So we've got not verified, limitation if you couldn't do it for whatever reason. If it's not applicable, like if it's a, you know, talking about a generator or solar panels, well, if it ain't there, then it's not applicable. As I said, sometimes you have to do a bit more investigation, and you might not have time at the time of the report, so it gets an FI. A C3 generally is things that aren't really dangerous, but maybe not up to the latest regs. So previous editions of the regs, you know, you don't have to retrospectively keep up to date. So if you were installed on the 16th edition, like this install was, then anything regulation-wise that's come after that, I can only really mark it down as a C3. It's not to regulation, but it doesn't compromise the safety of the install. Could be better, you know, we're not saying it couldn't be better and be improved. You know, it does say improvement recommended. You know, there seems to be a bit of a trend in people ignoring those, but, you know, that's not what we're saying at all. C1 and C2, obviously these are the ones that could be dangerous. C1, I've never actually issued one, because I tend to kind of make it safe at the time, and then it becomes a C2. But yeah, so for me, C1 is exposed live parts that are accessible. So if it's like right up at the ceiling, 14 feet in the air, and you need to get a step ladder to it, although it's an exposed live part, is it immediately dangerous? Well, you know, not really. If somebody could accidentally bump into it, or maybe put something in a cupboard and accidentally get a shock, then yeah, C1. But yeah, it's a very rare one for me anyway. Mostly it comes down to C2 or C3. And we just go through all of these questions. As you can see, I'm a naked man. And I just like the layout of their stuff, actually. It just looks nice. And it's color coded. We've got the code breaker type codes here. But yeah, that is schedule of inspections. So let's get back to the report. Cool.
So this is the board. Now I'm isolated upstairs and I've locked off. It's in a public ways. Anyone can open the cupboard, and what I don't want is anyone turning it on. So it's padlocked off. I've checked. This is all dead. We're happy days. But we're doing continuity of bonding conductors, and if you can have a look here, I'm just going. So this one I've confirmed as my main, sorry, it's the earthing conductor. It's not the main one anymore, Craig, come on. And so is this. So this is from the twin and earth that supplies the board, and this is like a supplementary conductor that they've added because they wasn't confident that this was enough. This one. So those ones are eliminated, but we've still got 3 here. 1, 2, and then we've got 1 down here, gas it says, but we don't know. So what I'm going to have to do, I'm going to get a what we call an R2 lead, which for me is just a long bit of wire, and I'm going to take this one out, start with this one, join it to my wire, and then run my wire, which is here. So I'm going to join my arbitrary bit of wire, sorry, there, and run that to the water stopcock, which I've done, and hopefully we get continuity between my R2 wire and the bonding clamp. So it's right back there. I don't think you'll be able to see that, but I can get to it. It's not the end of the world. Obviously we wish they were more accessible. Can you see the pipe there? Oh, it's really hard to get. Oh, whatever. It's in there, trust me. So yeah, we are hoping for continuity there. Don't know, but we're going to go through one by one until we find it. If we don't find it, then it's not there as far as we're concerned. So we might need to run a new wire or find out where something's gone wrong. Okay, so I'm just going to set the tripod up for this because I can't hold it and do it. Right, so I've joined it at the board. So I've taken the bonding conductor right out and linked it with my R2 lead, which is my bit of flex. Now this test kit also knows the leads, and you join them together, which is kind of, well, it's just that's Star Trek stuff for me. I never had that with my first test kit. I always had to deduct the lead resistance by joining them together, press test, write it down, do my test, then deduct that amount. But brilliant now, isn't it? Okay? Absolutely brilliant. So I'm just going to give them a once over, check my leads, because anything dodgy going on there is just going to send me up the garden path. I don't want that. But they're all good. So let me just null them again. There we go. So what I'm going to do, I'm going to clip my, it doesn't matter which one really, one of them onto the bonding clamp under the sink, one of them onto the end of my R2 wire, and that kind of completes the circuit because it's going to go down this lead, down the bonding wire, to the board, joint with my R2 lead, back down the R2 lead to here and back into the meter. Happy days. So let's see what reading we get. Okay, so I don't know if you can see that, you probably can't. It says 0.19. Now, as I said, they've auto-nulled them leads. So what we need to know now is what the resistance of our R2 lead is. So I'm just going to go and disconnect that and bring it back here, and then we'll measure what that is and deduct it from the 0.19. One sec. So now I've got both ends of this lead, I can test resistance of that. It hasn't turned off, so they should still be auto-nulled. And so the R2 lead is reading 0.18, which means our bonding conductor, which is now confirmed as a single conductor from the board to that pipe, and we got a value of 0.01, which is pretty good. So I'm going to do the same thing for the gas pipe, but I'm not going to show you that. It's exactly the same process. I'm going to take out the bonding conductors, join them, go to the gas meter, clip one of them on my R2 lead, one of them on the clamp, and do exactly the same thing again. Join me on the R1, R2s. So, R1, R2 time now. I'm going to do an R1, R2 for every circuit, obviously. First one is the hob radial. So all I've done, I've taken the line conductor out and joined it with the CPC. And all I've got to do now is go back to the hob isolator and put one probe on the live incomer and one probe on the CPC. Now it's a metal clad front plate, so what I also like to do is just check that front plate, make sure it's not too much of a higher reading, just in case there's any corrosion in there or just a poor connection. So let's go there. Okay, so there's not a lot of light here and there's not a lot of access, but by opening this I've just found, you know, a little problem. It's not a massive deal, but I can see that the sheath isn't quite in the box, and you get that a lot with these isolators. You know, they're big cables and they are hard to dress back nicely, but it's always the problem. So one probe out on the CPC and one on the live, and on this isolator that's coming in the bottom. We should get a reading, and we do 0.12. Cool. So once you get the ZE later, you can add those together to get a calculated ZS, which is a bit better than a measured one really, because it's the worst case scenario. No parallel paths. So next I'm going to do the same thing as I did with the hob isolator with the lighting, and that involves exactly the same process at the board. I'm going to take the live out of the breaker, join it with its CPC, and then I'm going to go to every single switch and light and make sure I get a reading. The further it gets away from the board, we're hoping that that reading increases. It might not if they've used joint boxes, but again that might highlight another problem if I don't know where it is or there's no access to it, so that might get marked down as well. So all the time as you're going through, you're just noting all these little issues along the way. I'm not going to film that because I've got to crack on. They're paying me by the hour and doing a video is kind of taking the mick. So join me on the ring circuits because that's a little bit different to the R1, R2. But yeah, lighting, you join line conductor with the CPC at the board, go to every single point on the line circuit, so switches and light fittings, and take a reading, and you record the highest one. Okay, and then again once you've got the ZE later, you can add that to get a calculated ZS. Just doing the R1, R2 on the lighting circuits, and found a little problem. This plate isn't actually earthed, so that's something that'll be a remedial, but we can still get a reading. Okay, good. So again, jumping around, about 0.9, 0.92 I'd say. So that's something we'll have to link out a bit later. Got the same thing here, not earthed, but still get a reading. And it is a little bit higher than the last one, it's a little bit further away, so it's what we expected. Okay, check the other side, and I'm going to just check that up a bit at the switch, just a bit of a functional check really of that switch whilst it's dead. Yeah, happy days. Gotta get a strap. Okay, good. So, ring testing. First thing, zero the leads. Done. We're going to do continuity of each ring, so live to live, write it down, neutral to neutral, write it down, CPC to CPC, write it down. So, there's my two live legs, one on there, one on there. I'm getting 0.28. Okay, same again but on the neutrals. Make sure they're not touching, obviously. And then we're getting 0.3, so about the same, which is good. Now CPC, it's a smaller cable, so we're expecting this to be a bit higher. Okay. All over the place, that one. Let's just let it settle down. 0.93. Okay. Yeah. It's all right. So first, next step is to write them down first before you forget, and then you're going to do your live neutral or R and RN. So we'll get on that next. So once you've done that, we take the live from one leg, join it with the neutral of the other, and vice versa. And we're going to take a reading here, which for me is the most challenging thing because I haven't got a strap, but here we go. So I'm getting 0.07, 0.07, yeah, 0.07. So now I'm going to go to every socket between live and neutral, and we should get about the same reading. So, as I said, come to each socket between live and neutral, take a reading. Should be about the same as what it was at the board, and it is. So I'm going to go around doing that for every socket now, which is a bit laborious but worth doing because it'll highlight whether it's wired in a ring or not and any polarity issues. So we're doing that with the live and neutral. Then I'm going to do exactly the same thing at the board with the live and the line and the CPC. So take the line from one, CPC to another, join it, and vice versa with the other leg. Take a reading at the board, and then I'm going to go to every socket but between live and earth. Okay. So live to earth crossed 0.18. Again, check every socket. So live earth now. And look at that, 0.18, brilliant. So again, I'm going to check every socket, make sure they're all substantially the same. Next one. 0.18, 0.19, that's a good one. And so on. Just write all these readings down and we're going to record the highest one. insulation, hold on, get them on. Okay, so insulation resistance time now, and I've done something funny here. We got LED lights, they're built in, and I've checked, they're not on plugs, and the amount of work to disconnect all of them, I'm going to destroy the decorations. So I spoke to the owner and I said, look, I can link out live and neutral and test against earth, and then we don't have to disconnect them all. It's still going to go down, the fact that they're not easy to remove for this purpose. So it'll be a defect, whether or not he'll decide to do anything. I highly doubt, to be honest, because it's just not really cost efficient, is it? But here we are. So I'm going to do insulation resistance in kind of 2 hits here. I've got this side of the board, this is a split load board. Isolator's obviously off. I mean, we're locked off upstairs anyway, but I don't want anything going backwards down the submain. So I've just isolated that, and I'll test that separately later. This part of the install though, so we've got the hob, the boiler circuit, which we already knew was a problem, and I've tested that individually, and yeah, there's a problem. We've got essentially a live earth. There's no insulation resistance at all. So we've got a major earth fault on that cable, and I can't find where the fault might be. It's somewhere under the floor. It's a basement flat. We're not going to get to that. So the only option really is to rewire that circuit. They've got like a nice wooden flooring, and it's not worth it. I can do a nice surface run, and I can hide it and blend it in. We've got a route, we're going to do that. We also need to run in some power for TV point later anyway, so we might as well keep the same route. So boiler circuit's out the question really. I'm going to remove the neutral and the CPC off that circuit in a sec before I test, because it might throw up anything. So let me just pause you while I do that. Okay, so neutral, CPC, and the line conductor of that boiler circuit is now out. So what am I testing here? Well, I'm going to put a probe there, and with all these breakers on, that's going to send 500 volts through the line conductor of the hob, the 2 lighting circuits. But you see I've linked the live here with the neutral bar, so actually the 500 volts is going to go down the live and neutral at the same time, so you've got no potential difference. So these lights, they're not going to get damaged or anything like that. So one probe's going to go down here, and the other probe's going to go against CPC. Again, got this problem with the strap. God, see, when you don't do this every day, you don't really think about these things, but my God, without a strap, I've got real problems here. Let's see. Will my hands reach there? No. Okay, so let's put the, oh my God. So no, I'm going to have to make a strap. It's ridiculous. Okay, I'm back. Remember that R2 lead? Yeah. Well, now it's a strap. You had to do that with a proper R2 lead. And also, even better, I found the remote lead, but I don't know if it works. So I need to check that first. Just join them together. Should get a 0. We'll get 0 when I plug that one in the right place. No. So I don't think that lead's working. Damn it. Bear with me. So remote lead doesn't work. The button works, but it's not giving me any continuity through the actual lead. So that's annoying. So I've managed to find a way of holding this. I've got my strap now, so now I can press the button. Should be good. It's linked, yep. Everything has been linked on. Oh, incidentally, before I did this, we turned all the light switches on So if the power was on the lights would all be on. So I'm going to do it once like this, and then I'm going to flip the two ways and just do it again to make sure I do test all of that circuit. So global readings I'm getting, it's not great, it's about 75, 76, it's creeping up, which tells me somewhere there's probably some damp, which is, you know, kind of likely in a basement flat in the middle of Brighton. So it's creeped up to 82 megohms now. You can see that, 83, and it just keeps going up, so it's almost certainly damp. So I'm going to record 70, that's where it started. Now I'm just going to flip these two ways. Do it again. Get my special hand grip. Boom. Yeah, again, started off at 50, creeping up. 61 now, 63, 64. So yeah, we're looking at a bit of damp in here really. So I'm just going to flip the other two ways and then do it one more time. So now the lights are in the on position again. My special grip. And we're off. So starts at 36, it's crept up straight away to 60. So I think overall I'm about 40, because, you know, globally it all brings it down. So I'm going to test that one, and then I'm going to have to kind of calculate the two, because we need to know the whole install complies. You know, it's kind of misleading. You might have a high reading there, a low reading there, which actually brings that one down lower than to that one. Does that make sense? Parallel resistance. So I'm just going to rearrange this, test this side, and then we do a bit of math. So the same thing again, I've linked out from there to there. So this lead, it's a bit easier to hold now. This lead is going to link the lives of the ring circuit and the neutrals together. And then I'm going to, well, I am putting the probe on the earth bar. So when I press test, I'm testing all of these circuits together. What we got? I started off a lot higher there. We got 80, 90, yay, over 100. I mean, that's a lot better, isn't it? But like I say, you know, we don't want to just assume that it's 100, because that one started lower, and the lowest I kind of saw that was about 30, 40. Sort of flashed 30 and then straight to 40. But, you know, very jumpy when things are damp. So I'm just going to, let's just see if that settles this one, and then I've got a number to work with. So yeah, it started on 83, so I'm going with that. 83 that side, I'm going to say 36 for that side, and then do parallel resistance equation, and I can work out what the installation resistance is globally for the whole install. Now, regs say it should be 1 megohm for this type of circuit, but you always want it better than that. For a new install, you know, if you had anything less than 20 megohms, you'd have to investigate. But personally, a brand new install, I'd want it over range. Otherwise, something's gone wrong, isn't it? So there we go, installation resistance, bit of maths next, and then that's done. And the last thing we've got to do is the live test. So I'm going to start with the ZE. So I'm going to take that out. I'm going to have to put all this back together, take the lock off upstairs, keep that off, and then I've got my live, my neutral, my earth. It's important to make sure you take that out, otherwise you're going to pick up all these parallel paths and you're not going to get an accurate reading. We need a good ZE. We've done good R1, R2s, so I'm going to, you know, add the two together and put down a calculated ZS. And then once I've done my ZE, I'll put that back in, put everything back on, and then I'll do some measured ZS's. And what I'd expect is the measured ones to be lower than the calculated ones, because the measured ones are going to pick up all the parallel paths. And as long as that happens, I'm happy. And then the last thing I'm going to test is this little baby here, the RCD. It's 30 milliamp RCD, it's Type AC. They're going to change this board anyway because it is a little bit out of date. I reckon this was probably 2006-ish, something like that, when it was installed. We got no idea, there's no paperwork. It's my new ringtone. So there we go. When I change this board, obviously we're going to go with Surge 1 and 2, and we're going to be changing these to RCDOs. And I'll go for Type A, I think, seems to be the trend. And with all the LEDs in the place, and they're only going to fill it up with lots of computers and DC stuff. So it's probably a good idea. Right, so the next thing I'm going to do then is kind of put everything back together, seal everything up and get ready for the live tests. Righto, so ZE now, and also prospective fault currents at the same time. Oh, come on, lead. I don't know why they make these leads out of rubber, because they really tangle. Does make them more flexible. Anywho, so I got two earthing conductors. This is the sub main down. So this is actually ZSDB that I'm doing here. I'll do a ZE later upstairs, but I need to know this one here, and then I can add that to the R1, R2s, and then do a final ZE upstairs. So all I'm going to do, I've undone the padlock upstairs. I now should be getting a live result, and I am. No, oh, it's already gone and done the test, but that was on 3 low. I don't want that. Let's see what it comes up as anyway. So 0.02, that's great. There we go, it's on the right setting now. I went out on a higher current for the ZE because you get kind of interference in the street. So with the higher current I'm getting 0.07 ohms and 3.14 kA, which is great. That's a good result. Okay, so technically that's ZSDB, and I just want to explain why there's two there. So we've got a twin and earth coming down there, 16mm, and they've also put a 16mm kind of supplementary conductor with that, which is good. But it means I have to disconnect both of them and clip onto both of them. So there we go, 0.07 and 3,140 amps if live to earth touch. Happy days. Now, no, too high, there we go, toggle that. Happy days. What's next? Measured ZS. So just going around doing measured ZS now, so this is easy. Just plug them in and press test button. Obviously put it on the loop reading. Not going to bother tell you how to use this one because yours might be different, so read the instructions. Good, so again 0.28, which is about bang on what I was expecting. I was expecting it to be a bit lower for the measured, but that's alright. Maybe it just hasn't picked up a parallel path. Happy days, so I'm going to do that with all of them. I'm not going to show you that because my camera battery's running out and I've got the Rcd test to go yet. RCD time, half times first, 30 milliamps, 0 degrees. Should go over range, which it does. So now I'm going to toggle to 180, do the same thing. Over range, that's good. 1 times, should be less than 300 milliseconds. 36.8, that's a good one. I'm just going to try that again on the other phase. 26.6, that's good. And lastly, 5 times the rating, so 150 milliamps, 0 degrees, should be less than 40 milliseconds, probably will be. 17.6, that's good. And then lastly, 180 degrees 5 times, so 150 milliamps again. And 7.98, oh, that's good. Excellent. Now, I could have done that test at the board directly on the Rcd terminals, but it's just easier to plug it in like this. So there we go. That's everything now, isn't it? I've got to do the ZE upstairs yet, but run out of battery now, so that's the end of this video. See ya.